Hello everyone. In this video, we'll be discussing auctions. I'll be honest, economics is hard, but it could be interesting to see how a concept we know is being used in real life, to see how it plays out in the world of code. So, if you're someone who lives in India and reads newspapers, you see government, put inviting bidders and tenders for different government companies, different land, different projects, and so on. Now we see that auction being used in real life. In this video, we'll focus on a very specific type of auction called the second prize auction, also the vickrey auction, which won the Nobel Prize for economics. Now, this auction is slightly different from how you would imagine a typical auction process to happen. For example, let's take there are 10 bidders and all of them are bidding for a particular diamond necklace. Now, let's say the highest bid wins and it's $10 million, and the next bid is $9.5 million. Now, the person who bid for $10 million will win, but they'll pay only $9.5 million. Weird, right? So that's how second prize auction or vickery auction works. Vickery auction encourages people to bid fairly, but researchers have over time questioned how easy it is to, or how much fairness can you expect from an auction in real life if you implement this second prize policy. Now we will see how to implement a vickery auction example, or how to simulate it in Python. Now we have this Python code. We'll be using the random number generation library to generate random bids. So have this function called simulate auction that accepts the number of bidders, and we are generating a list of bids. So here we are assuming that one person bids only for one time, which is not realistic, but we will use it in this very simplified scenario to explain what vickery auction is, or how it works when you write it down in code. So you have a list of bids where the value is between 1 and 100. Next, you have a sorted list of bids from highest to lowest. So obviously, the winner will be the highest bid will be the first, or the index 0 in the case of list in Python. So it will be the value in index 0, and the amount that they will be paying is the second highest bid, which is the value in index 1. Now we are getting the winner index, or the bidders number or index, using the highest value bid, and adding 1 to it, because indexing starts from 0. Now if you try to run the code, you will see that there are 5 bidders, and these are the randomly generated values, highest being 99 and the second highest being 88. So in vickery auction, the person will be paying 88 million dollars, 88 rupees, whatever, but and the winners, what you can say, tag number or index number is 1. Now let's run it again. So we have number of bidders as 5, and then you have a list of generated bids, the highest being 93, second highest being 83. So now they will pay 8. The winner, the bidder who bid 93, will be paying only 83, and the index or the card number, you can say, for that bidder is 3. So 1 2 3, so they will be paying 83. This is the same code as what we saw previously, except we are running the simulate auction function twice, which means one person is allowed to, or like there is a series of rounds happening, a series of bids happening. Like there is a first round and there is a second round. Now, if we run the code, you can see that there are two rounds of auction happening, where in the first round you have different, like 5 bidders, and the second round you have 8. You can also set it to include just the same number of bidders, 5 and 5, or 8 and 8 in each round. So here's the sorted bids. 80 is the highest, so the person who bid 80 will win, but they will pay 65. Next, in the second round, the winner is the person who bid 98, but they'll pay 94. So this is how vickery auction works. I hope this video was helpful in explaining what vickrey auction is. So if you followed the Nobel Prize for economics over years, you would have heard of the vickrey auction. So I hope it was interesting to see how you can implement or simulate it in Python. Thank you for watching.